Hello friends, welcome again. Now we are going to understand and learn the new concept of power sequence, the new generations of the laptop like any after 5th generation like 6, 7, 8, 9. The sequence is more or less the same, only thing is some signals may be different depend on the motherboard to motherboard, like there are so many types of motherboard. There is the Compal motherboard, then Quanta motherboard, Inventec motherboard. The signal names may be little more different, but the sequence or more or less is the same. So here I am going to explain the concept of the new generations power sequence, and from that once you understand this concept, then you can able to repair any kind of new generation laptops. Like normally if the voltage is coming, then there is only the two choice, either SIO may be SIO may be faulty, or it may be CPU may be faulty, because the new generation laptop PCH and the CPU is a merge. So it's called a system on chips. It's called short form. It's called the SOC, system on chips. So we'll start the new sequence. So in the screen you can see there are some component, like here you can see this is a CPU. Then here you can see the RAM. Here you can see the BIOS, and here you can see the SIO. Now the SIs require a 3 volt, BIOS require a 3 volt, or the newer BIOS require a 1.8, and here is the RAM, it's a DDR4. Then DDR4 require there are total 4 voltages like 1.2, 0.6, 3.3 and 2.5. And the CPU is here. The CPU require a CPU core voltage, then 1 voltage, and then the 3.3 volt. So these are the power required to the CPU. Now here are my buck converter, here is my battery charging section, here is my adapter inputs, and here is my 5 volt buck converter, here is my 3 volt buck converter, here is my 1.2 volt buck converter, 1.05 volt buck converter, and here is my CPU core supply. So once I give the power, suppose if I give that 19 volt from the DC jack, here are my two MOSFET current and then the current sensing resistor. As soon as I connect the adapter, then the 18 volt pass, you can see here 18 volt pass to this two MOSFET, come across this current sensing resistor, and it goes to the different buck converter immediately on their upper gates. Like here is upper gates, here is upper gate, here is upper gate, and these are the 3 volt 5 volt buck converter chip. This 19 volt is reaching all this section before power button on. Now this all sections are remain on, this all buck converters are remain on, only this 3 volt and 5 volt section work in this, and particularly we are focusing the 3 volts. So as soon as the 19 volt reach to the input of this chips, then this 3 volt chip generate a 3 volt linear voltage. It's called 3VL voltage. So you have to check this 3VL voltage. 3VL voltage is a linear output from the 3 volt section. So you have to check that, and this voltage is going to the SIO. This voltage you can check on the SIO ST V standby pin. V standby pin, you can check this 3 voltage at the SIO V standby pin. For that you have to open the schematic diagram, and there you will see a V standby pin, and there you have to check this 3 volt. As soon as the SIO get this 3 volt, it start working, but before that you need some 2-3 signal, like then the SIO require SIO get this lead switch, that is a 3 volt. Then he received AC in signal, that is a 3 volt, and this EC reset, EC reset, EC reset, ECRST, that is a 3 volt. So once SIO get this V standby voltage, then the SIO get the reset signal, that is called the EC reset. Then the AC, that is the adapter current in signal, that is a 3 volt, and lead switch or the lead input signal, that is a 3 volt. Okay, and in normally this newer generation laptop, the EC bias is merged into the CPU. So there is a there is a no bias outside on the SIO. On the newer generation laptop, the EC bias merge into the SIO. Okay, so you won't find a bias outside or the SIO. So the bias will be on the SIO. The bias size, it may be somewhere around 128 kb or maximum say around 256 kb. So that is the size of the bias. Okay, for that you need a bias programmer to program the EC bias. So if the bias is okay and if the SIO is okay and SIO received all this 4 signal, like he received first supply, then EC reset, then AC in, and then lead switch, all the 3 volt. Then after this power button press, this is a power button, at the power button you will get a 3 volt, but once you press the power button the voltage goes to 0, and when we release the power button voltage come up to 3 volt. That means the 303 bounce will be created on the power switch or the power button. Okay. So once we press the power button, SIO receive all the information and he start communicating with the PCH, that is the PCH merge into the CPU. So immediately SIO starting communicating with the CPU and he send pulse, that is called the PM power button. PM power button is a post power button or the digital power button, and the meaning of this signal is that SIO asking CPU that the power button is pressed, now what to do. So SIO taking a basically SIO taking a permission from the CPU. So is sending this PM power button. So what you have to do is you have to connect multimeter here, and as soon as you press the power button you will find a 303 pulse at this pin at the PM power button. Okay, and if the pulse is coming here, that means the SIO is functioning, and if you won't get this pulse here, that means the probably SIO side is a problem. So you should get a pulse here at the PM power button. So after this PM power button pulse is going to the CPU or it's going to the PCH, then the PCH or the CPU or the SOC will respond and he will send the 2 signal, and those signal is called SLP S3 and SLP S4. Okay, so you have to check this both the signal SLP underscore S3 and SLP underscore S4. The both signal will become a 3 volt. Before power button the both signal will be the 0 volt. After pressing a power button the both signal will become a 3 volt. So you have to check that, and if these signals are coming, that means the CPU is okay, the CPU is responding, and if the signal is not coming, that means the something problem related to the SOC. Okay. So after receiving this SLP3 and SLP4 signal, then SIO start turning on different buck converters. So here are the different buck converters are there. So SIO will start turn on first this 3 volt and 5 volt section. You just generate the EC on signal and turn on the 5 volt and 3 volt. The 5 volt is going to the hard disk and DVD writer and audio amplifier and the USB, and this 3 volt will turn on, and this 3 volt is going to the RAM, then BIOS, then CPU, then Wi-Fi, then network, the different chips this 3 volt is going. Then after that EC on, the SIO will generate the another signal is called the sys on signal. The sys on signal is basically used to turn on the RAM supply. So here is my RAM is a DDR4. So DDR4 requires a 1.2 volt. So the SIO will give the enable signal to this particular buck converter. This particular buck converter generate a 1.2 volt, and this 1.2 volt goes to the RAM and the CPU. Then the next signal is called SUSP signal, suspend on signal, and that SPSP signal generate a 1.05 voltage that will goes to the again to the CPU, and it is turn on the RAM VTD supply also. This 1.05 voltage will be generated, and this 1.05 voltage goes to the SOC or the CPU. SOC and the CPU is both things are same here, because the SOC I already told you that the SOC means the system on chips. System on chips means the CPU and the PCH is merged into the single chips. So that is why it's called the SOC, and here is a 1.05 is going to the PCH side or the PCH section, and then after that this SUSP signal give the enable to this RAM section also, because the RAM require total number of 3 voltages. So here 1.2 is already given to the RAM, 3.3 also given to the RAM. Now the next voltage, that is a 0.6 voltage, that is a VTT, will be given to the RAM. Okay, so 0.06, that is VTT voltage is given, and after that 2.5 voltage also generated by using a 3.3 volt. So total there are 4 voltages given to the RAM on DDR4 sections or DDR4 RAM. Okay, so now the finally most of our components or most of our chips is turned on, only one chips is still not turned on, and that is a CPU. Now the CPUs require a core voltage. So this is my core voltage, this is my CPU core voltage, and to turn on the CPU core voltage, SIO should give one enable signal, and that signal is called a VR on signal, and then after generate all the signal, then SIO generate this VR on signal and give enable to the VRM circuit or the VRM buck converter. After giving the enable to the buck converter to the VRM section or the CPU core section, then VRM section generate a CPU core voltage, and that this voltage is somewhere around 1 volt to 1.8 volt. Okay, here the CPU core voltage is not exact voltages, because at CPU core voltage is considered to be in the current. So the rest of the voltage are the fixed, like here is a 1.05 volt, 1.2 volt, 0.6 volt, these are the fixed voltage, these are the accurate voltage. But on the CPU core there is no accurate voltage, because the CPU core voltage is considered into the current. So that is why when we check the CPU core voltage, that time will find there sometime 1 voltage, sometime 1.2, sometime 1.5. The voltage will be variable, because there is require a current, then that current is very high. Okay, so CPU get this core voltage. Okay, so in this way the all powers are turned on, and then the laptop is turned on. So my dear friend, in this way I explain you how this power sequence work in a newer generation laptop. So simply you have to follow all the signal which I mentioned here in this chart. Okay, and now we'll see what will happen if my laptop is not turned on, and which are the signal we have to check on the laptop not turn on in the new generation's motherboard. So let's start our next session. So here is my SIO. Suppose if your laptop is not turned on, then which are the signal you have to check on the SIO. So first thing, you have to check this V standby voltage, this 3 voltage at the V standby pin, and that is a 3 voltage, that is the first test point. So if this voltage is not coming, then you have to focus, or you have to see those 3 volt linear section, and the 3 volt chips may be faulty. So first thing is require a 3 volt at V standby pin, that is number 1. Then number 2 is SIO require a reset signal, so you have to check this reset signal, that is also 3 volt. Then next, third number is a AC in signal, AC in signal, so you have to check this AC in signal, so that is a 3 volt. And then lead switch signal, that is also 3 volt, and then next thermal trip signal, that is also 3 volt. So most of the all of the signals are only 3 volt only, so you have to check all the signal 3 volt. If one of the voltage or one of the signal is missing, then you have to focus, or you have to find why this signal is not coming to the SIO, and if one of the signal is not coming on the SIO, then SIO is not going to turn on your laptop. So my dear friend, so at that time you have to see where is the problem. So in this way, these are the 5 signal you have to check. It's very simple, it's a very standard, so you don't have to worry about it. So simply you see the diagram and check all the 5 signal, and the important thing is all the 5 signals are only 3 volt. So it's very easy. Okay, after that, if your 5 signals are okay, the next signal is the bias, EC bias. Now in the newer generation, the EC bias is merged into the SIO. So If the all 5 signals are coming but still your laptop is not turning on, then you have to flash the EC bias. Okay. Now if your EC bias is also okay, the next signal is this power button. So the power button is a 3 volt. Okay. So and the power button is called the NBSW on or power button or on off switch or on off button, something like that. So you have to see the diagram and find this name. Okay, and there you will find a 3 volt. Now once you press the power button, then that 3 volt goes to the 0. Once you release that button, then it goes back again to the 3 volt. So now you have to check this 303 variation on the power button. Okay, it should come, and if this variation is not coming, then in that case your power switch is faulty or something related to the power switch is faulty. So you have to focus there. Now if this 303 variation is coming, that means your step 7 is complete. Okay, now whatever the inputs are required to work the SIO, all are given to the SIO. Now the turn of the SIO. Now the SIO should send out 2 signal. These are the 2 output. Here we see all the input signal. So step number 1, step number 2, step number 3, step number 4, 5, 6 and 7. These are all input signal. Now these are the 2 output signal. The signal name is RSM RST and the DNB WR on or the PM power button or PBTN, either of this name. This is called the post power button or the after power button press, and this signal is going to the SOC and informing the SOC that the power button is pressed. Now what to do? So this is a output signal going from the SIO to the SOC. So here you will find a 303 variation after pressing the power button. So you have to remember this very important point. So now once you press this power button, you should get RSM RST 3 volt and you should get that DNB WR on is a 303 variation. And now if this 303 variation is not coming or the RSM RST is not coming, and if all the input signals are coming properly, then there is 100% sure that your SIO is a faulty. Okay, in that case you have to replace the SIO. It's a very simple. Okay, I hope you understand and you can able to replace the SIO. So next thing will go to the SOC or the PCH side. Now in this screen we are going to learn what the things are required to work the SOC or the PCH. Okay, so here is my SOC or the CPU, and now what the things or what the signals are required to the CPU or the SOC. First is require a RTC VCC, and the RTC VCC is a 3 volt, RTC reset requires a 3 volt, VCC DSW is a 3 volt, DPWR okay, these are 3 volt. Wherever these are red colors, the red color are the supply or the voltage and the blue color are the signal. Okay, but all where you should get a 3 volt, like you will get here a 3 volt, you should get here a 3 volt, then 3 volt, then 3 volt, then the 3 volt, then the 3 volt. Okay, so these are this only the output signal. All these up to here are the input signal. Okay, these are the input signal and all the signal are 3 volt. Okay, now once he get this RSM RST and then he get the signal power button or the DNB power button which is coming from the SIO, and this signal will 303, the bounce will be there, is going to the CPU or the SOC. 303 bounce sent by the SIO. At that time this SOC should send out this 2 signal. SOC should send out this 2 signal, and this is going to the SIO. The signal is called SLP S3 and SLP S4. These 2 signal come out from the SOC is called SLP S3 and SLP S4. So if these signals are not coming, if this signal is not going to the 3 volt and if it remain a 0 volt only, in that case your CPU or your SoC or the PCH is bad. It depends on generation to generation. If up to the third generation, this a PCH will be there, and after a third generation this CPU will be there, okay, or it's called SoC. So you have to check all the signal one after another, and you will check this output signal, that is called SLP S3 and SLP S4, and if these signals are not coming, then the SoC is faulty. So my dear friend, in this video I explain very simple way and very authentic way the test point of the motherboard. In this animation I explain how the signals come out and what are the test point you have to check on the SIO and what are the test point you have to check on the SoC to rectify the dead laptop. Okay, I hope you understood this concept and the sequence. So thank you very much.